Good day everyone, and we are the Group 6.
I'm Syra Joyce Corpus from Group 6 of BS Ed Math 3B. And for this video, we're going to answer item number 5 of chapter 6.2. And for our problem is the average number of calories in a 1.5 ounce chocolate bar is 225. Suppose that the distribution of the calories is approximately normal with the standard deviation which is 10. And now we're going to find the probability that a randomly selected chocolate bar will have. So we have for our A, we have between 200 and 220 calories. And for our B is less than 200 calories. So for our first step, we're going to draw a figure and represent the area. So as we can all notice, so we have here our mean is 225, right? And our problem is we need is the between 200 and 220. That's why the shaded part will be at the 200 and 220. Next, for our second step, we're going to find the 2z value. So how we can find the 2z value? First, so this is our formula. So we have the score minus the mean all over standard deviation. Z represent for the score, and this is our mean, and this is our standard deviation. To find our first z value, so again, our formula, score minus mean all over standard deviation. Our score is 200 and our mean is 225 and our standard deviation is 10. That's why 200 minus 225 is negative 25 all over our standard deviation, which is 10. And if we're going to solve this, we have negative 2.5 for our first z value. And now let's move to the second z value because we need to find 2z value, right? So again, our formula is score minus mean all over standard deviation. So for our score is we have 220 minus 225 all over our standard deviation, which is 10. So 220 minus 220 minus 225 is negative 5 all over standard deviation. And if we're going to solve this, we have negative 0.5. And now for our third step, we're going to find the appropriate area using the table E. So for our second z value, we obtain negative 0.5. That's why if we're going to find the appropriate area of this using the E value, using the table E rather, we obtain or we have 0.3085. And for our first z value, we obtain negative 2.5. That's why if we're going to find this, the appropriate, if we're going to find this using that table E, we have 0.0062. And now, we're going to minus the what we obtain at the first z values and to the second z value. So we have, for our second z value, we have 0.3085 minus 0.0062, and that's why our final answer for A is 0.3023. And next, for our letter B is less than 200 calories. So as we also do for our first step here at to our letter B is we we need to draw a figure to represent the area. So since we're going to, our problem here is less than 200 calories. So as we can see, the shaded part will be less than 200 calories. It's 200, not 220. I'm sorry for that. And now the step 2 is we're going to find the z value for 200. So our z, again, our formula, we have the score minus the mean all over standard deviation. So our score is 200 and our mean is 225, and our standard deviation is 10. So 200 minus 225 is negative 25 all over our standard deviation, which is 10. And if we're going to solve this, we obtain negative 2.5.
And now for our problem for item number 13, we have the average time for a mail carrier to cover a route is 380. If one of these trips is selected at random, find the probability that carrier will have the following route time. Assume the variable is normal distributed.
A is at least 350 minutes. For B is at most 395 minutes. And for C, how might mail carrier estimate a range for the time he or she spend and wrote? We're going to use this formula. So we have Z is equal to score minus mean all over or divide standard deviation. So this is our formula. So X is the score, and this one is mean, and the standard deviation. So for A, we have at least 350 minutes. Again, our formula, Z is equal to score minus mean all over standard deviation. So for our score, we have 350 and our mean is 380 all over or divided by 16. So if we're going to 350 minus 380 is equal to negative 30 all over or divided by 16. And so we have negative 30 all over or divided by 16. So we have negative 1.88. Now, if we're going to plot negative 1.88 to our curve, it falls to the left side of the mean. And if we're going to find the area of the z-score of negative 1.88 to the table E, we have 0.0301. And now, here we're going to multiply it to 100. So 0.0301 multiplied by 100. So our probability of at least 350 minutes is 3.01%. And now for our letter B. So sorry for this typographical error. So it is at most 395 minutes. Again, we're going to use our formula, which is the Z is equal to score, which is X minus mean all over standard deviation. So for our score, we have 395 minus 380. And our standard deviation is 16. So 395 minus 380 is 15 all over or divided by 6 our standard deviation, which is 16, and we obtain 0.94. If we're going to plot 0.94 to our curve, it falls to the right side of the mean. And if we're going to look the area of the C score, which is the which is the 0.94 to our table E, we have 0.828264. And now here, because it is at most, we need to we need to subtract 1 to our area, which is so we have 1 minus 0.8264. So we have 0.1736. So our probability of at most 395 minutes is 17.36%. And now for our
Good day guys, I am Lanson M. D. Guzman from BSED Math 3B, and today I'm going to answer some question in exercise 6.2. So let's start first with item number 21. So the first thing we will do is to read and analyze the question. Cost of personal computers. The average price of computer is $949. If the computer prices are approximately normally distributed and a standard deviation is equal to $100, what is the probability that a randomly selected personal computer costs more than a $1,200? The least expensive 10% of a personal computer costs less than what amount? So here, let X be the amount a least expensive PC can cost. So Z is equal to X minus the mean divided by standard deviation. So we will have 1,200 minus 949 divided by 100. So we will have 251 over 100. And 251 divided by 100 is equal to 2.51. And now we will look for the corresponding Z value of 2.51, and it is equal to 0.9940. After we get it, we will subtract it in 1. So 1 minus 0.9940 is equal to 0.006 or 0.6%. As a probability that a randomly selected PC costs more than $1,200. And for the least expensive 10%, as you can see in this picture, the corresponding Z value of 10% is negative 1.28. Since we have now the value of Z, the mean, and the standard deviation, we can now look for the X using this formula. So X is equal to Z multiplied by standard deviation plus the mean. So we will have negative 1.28 multiplied by 100 plus 949. So the answer is $821. So let's proceed to the next item, which is item 29. So the first thing we will do again is to read and analyze the question. Wristwatch lifetimes. The mean lifetime of a wristwatch is 25 months with a standard deviation of 5 months. If the distribution is normal, for how many months should be a guarantee be made if the manufacturer does not want to exchange more than 10% of the watches? Assume that the variable is normally distributed. By simply looking at the question, it's given that our mean is 25 and a standard deviation of 5. So using the distribution table, 10% or 0.10 is equal to negative 1.28. So since we have now the value of mean, standard deviation, and z-value, we can now find or we can now look for the value of x. So we will use the given formula where x is equal to z multiplied by standard deviation plus the mean. So we will have negative 1.28 multiplied by 5 plus 25. So negative 1.28 multiplied by 5 is equal to negative 6.4, and negative 6.4 plus 25 is equal to 18.6. So the final answer is 18.6 months. And the last item we're going to solve is item number 37. So again, we will read and analyze first the question. So in a certain normal distribution, 1.25% of the area lies to the left of 42 and 1.25% of the area lies to the right of 48. Find mean and the standard deviation. So the figure will look like this. So as you can see, the figure is symmetric. So since the normal distribution is symmetric, the mean will be the average of two limits. So 48 plus 42 divided by 2 is equal to mean. So 48 plus 42 divided by 2 is equal to 45. Therefore, our mean is 45. And now, let's look for the corresponding z-value of 1.25%. As you can see in this picture, the corresponding z-value of 1.25% is negative 2.24. So we can now look for the value of standard deviation. In this situation, we will use the formula z is equal to x minus mean divided by standard deviation, where x is equal to 42. So we will substitute the given value. So we will have negative 2.24 is equal to 42 minus 45, which is the mean, divided by standard deviation. So to simplify, we will have standard deviation is equal to 42 minus 45 divided by negative 2.24. It will result to negative 3 divided by negative 2.24. So the final answer will be 1.3. So in this question, the standard deviation is 1.3 and the mean is 45.